Hello everyone. In this video, we will look at the End Sem examination questions of numerical analysis and design. So the first question we have is a given a non-linear equation f of x is equal to x square minus x minus 1 is equal to 0. Apply various numerical methods to find its root. For any one of the numerical methods, bisection or fixed point iteration, perform the following task. In this question, we will use the bisection method. So the tasks are: describe the algorithmic steps or present a flowchart for the method clearly indicating initial conditions or assumptions, iterative formula or rule, stopping criteria, numerical results. Draw the flowchart for iterative calculation step by step, geometrical interpretation illustrating how the method approaches its roots, and then estimate the error at each step. So for this we will start with algorithm. So define the function f of x, which is x square minus x minus 1. Input the interval from a to b such that f of a into f of b is less than 0. Then input the tolerance epsilon, which is error limit. Repeat until the error is less than epsilon. Find mid, which is a plus b by 2. If mid is equal to 0, then root is found. Return mid. Else if the f of a into f of mid is less than 0, then b is equal to mid. Else a is equal to mid. Print mid as the root approximation and then stop. So now we will look at the flowchart. So this is the flowchart. We will start, then read the values a, b and the epsilon. Then while b minus a is less than epsilon, then mid is a plus b by 2. Then we will check by if else method. If f of mid is equal to 0 and it's the yes condition, then we will print the root and we will print the root is found. And if it is not equal to 0, and then we will check if f of a into f of b is less than 0. Then we will see if b is equal to mid or a is mid. Then by checking these a and b, we will continue the while loop which we started earlier until we find the until we get the mid is equal to 0 and the roots we are searching for. The next is the graph. These all values f of a1, f of a2, f of a3 are positive, f of b2 and f of b1 is negative, and this is where the graph cuts the x-axis is the root we are finding. Error and convergence analysis. Error at each step is equal to b minus a by 2. As iterations increase, error halves. This shows linear convergence. Bisection method has order of convergence, that is slow but guaranteed convergence, which means that the bisection method is slow but the convergence in this method is always guaranteed. The second question we have is: consider following data points 5, 150, 7392, 11, 1452, 13, 2366, 17, 5202 using Lagrange or Newton interpolation formula. Estimate the value of the function at x is equal to 9 for the chosen interpolation method. Perform the following tasks. So the tasks are: describe the initial assumptions or preconditions, the general formula or reoccurrence relation used in the method, any stopping criteria if applicable based on desired polynomial degree. Compute the value of f of 9 using the polynomial. Compare the interpolating polynomial with the actual data points on a graph. error estimation, absolute or relative. So given are the 5 data points: 5 and 150, 7 and 392, 11 and 1452, 13 and 2366, and 17 and 5202. So we use the Lagrange interpolation formula to estimate f of 9, which is f of x is equal to summation of y1 into pi j is equal to 1, I is equal to 0 to n, x minus xj upon x minus I minus xj. So using the formula, we estimate the value of f of 9 is approximately 810. This is the graph which shows the interpolating values which increases exponentially, and at f of 9 we can see it gives the value 810. So the error approximation: exact function unknown, so no actual value of f of 9 to compare, but interpolation is smooth and 9 is within the range of known values, so low error likely. Relative error: if actual available, relative error is equal to f actual minus f of 9 upon f actual. The third question we have is, you are given the following set of data points. These are the same values that we used in the that were given in the previous question. Using suitable numerical differentiation techniques, estimate the first and second derivative of the function at x is equal to 9. And these are the given tasks: describe the algorithm, present intermediate result and the final value of the derivative, estimate the error in derivative if possible. So the algorithm is start, then we will input data points which is x0, y0, x1, y1 till xn, yn, whichever the values are given. Then step 3 is construct Newton's divided difference table and calculate first divided difference. F of x0, f of x1 is equal to f of x1 minus f of x0 upon x1 minus x0. Keep building higher order divided differences. Step 4, construct Newton's interpolating polynomial f of x. Step 5, differentiate p of x symbolically on or term by term. Step 6, evaluate the first and second derivative of p of x at x is equal to 9. And step 7, output the result. The data points: x is equal to 5, 7, 11, 13, 17, f of x is equal to 150, 392, 1452, 2366, 5202. So the first derivative at 9 will be approximately will be 320.16, and the second derivative at 9 will approximately be 68.67. So the fourth question is, obtain formulas for numerical quadrature and obtain Simpson's rule from it. And the second part is, write algorithm for Vidal's rule. So the first part we will see general quadrature formula, which is f of x dx. We are integrating it in the intervals from a to b, is approximately equal to summation of wi dot fxi, in which I is equal to 0 to 1, where xi are the sample points in interval a to b, n is the number of points used. And derivation of Simpson's rule, we will look at it 1 by 3 rule from quadrature formula. To derive Simpson's rule, we approximate the function by a second degree polynomial over the interval a to b. Divide the interval into two equal parts, giving us 3 points. x0 is equal to a, x1 is equal to a plus b by 2, and x2 is equal to b. Using Lagrange interpolation, which is integration of fx dx from a to b, we have b minus a upon 6, and in bracket f of x0 plus 4 f of x1 plus f of x2, which is a Simpson's 1 by 3 rule. The second part, which is the Vidal's rule algorithm, it is start, then input functions f of x, limits a, b, and number of intervals, which is n. Compute step size h is equal to b minus a upon n. We have done several times. Initialize total integral I is equal to 0. For each group of 6 subintervals, compute x naught is equal to a plus h, x1 is equal to x1 plus h, and x6 is equal to x naught plus 6h. Then we will evaluate f naught is equal to f of x naught, f1 is equal to f of x1, and so on. F6 will be f of x6. Compute partial integral I is equal to 3h by 10 in bracket f naught plus 5f1 plus f2 plus 6f3 plus f4 plus 5f5 plus f6. So, and this we will add to total I is equal to I plus I minus I. Repeat for all intervals. Print final integral value I. The fifth question is write algorithm for computation of Gaussian quadrature formula for n is equal to 5 and evaluate pi from integration of dx upon 1 plus x square in the intervals of 0 to 1. So the algorithm will be input function f of x, limits a b, convert integral from a b to the interval minus 1 and 1 using change of variable. X is equal to b minus a upon 2 into t plus a plus b by 2. For n is equal to 5, use standard nodes x and weights w. Compute I is equal to b minus a by 2, summation of wi, f of b minus a by 2 xi plus a plus b by 2, output value of I. Then approximation of pi. Given integration of 1 upon 1 plus x square from 0 to 1, let f of x is equal to 1 upon 1 plus x square. We convert limits to minus 1 to 1 using change of variables. Using Gaussian quadrature formula, I is equal to 1 minus 0 upon 2 into summation of I is equal to 1 to 5 wi into f into 1 upon 2 xi plus 1 by 2. Evaluate using above values the final result, which is I is equal to approximately 0.7853981, which gives pi is equal to 4 into I, which is 3.1412. The question number 6, we have apply pivoting and solve given system of linear equations using any direct method. So we are given three equations: x plus 2y plus 3z is equal to 14, 3x plus 2y plus z is equal to 10, 2x plus 3y plus 2z is equal to 14, and by applying pivoting we have to find the value of x, y and z. So first we will write the content of the uh, equations in a matrix, and the largest value in column 1 is 3, so swap row 1 and row 2. So the row 1 and row 2 are swapped, so the new matrix is this one. Make the element below pivot in R2 is equal to 0. So multiplier for R2 is 1 by 3. So R2 is equal to R2 minus 1 by 3 R1. So 1, 2, 3, 14 minus 1 by 3, and the values in R1, which are R2, 3, 2, 1 and 10. So after calculations, we will get these values. Make the element below pivot in R3 is equal to 0. So multiplier for R3 will be 2 by 3, and R3 minus R3 is equal to R3 minus 2 by 3 R1. So after again we will make the following calculations, and the new matrix we will get is this one. So multipliers which are here, which comes are 4 by 3 upon 5 by 3, and by solving them we will get 4 by 5. So R3 is R3 minus 4 by 5 R2. This is the real multiplier, and we will get the values to be put in R3. So compute second element, third element, and then right hand side. These are the following values: 0, 8 by 5, and 24 by 15. Next, the new matrix we get is this one. So from row 3, 8 by 5 minus z is equal to 8 by 5. So the value of z will be 1. From row 2, 5 by 3 into y plus 4 by 3 into 1 is equal to 34 by 3. So by solving this, the value of y will be 2. And from row 1, 3x plus 2 into 2 plus 1 is equal to 10. So by solving this, the value of x will come 1. So after solving all these equations, we get the value of x is equal to 1, y is equal to 2, and z is equal to 1.